Alright, so we saw in the previous video how the methods of preparation of salts they depend upon their solubility in water. Alright, so we have two entirely different methods for the preparation of salts based on their solubility. If the salt is an insoluble salt, then we make it by ionic precipitation that we discussed over here as well. And if the salt is a soluble salt, then we have a few different methods for this. For example, we have acid plus alkali. We react an acid with an alkali and we get sodium and we get a salt and a water in this case. And this can be done if we want to produce sodium salts, potassium salts, and ammonium salts. In the background it says SPA, sodium, potassium, and ammonium salts. For these salts, we use acid and alkali reaction to get salt and water. And if we want to make some salts which are other than these metal salts, then we use either acid plus metal. We react acid with the metal to get salt and water as we discussed over here in these three methods, and or we do acid plus metal oxide or acid plus metal carbonate. These are the same methods that we discussed over here. Alright, so this can be done by all other salts if they are soluble in water. Whereas if the salts are insoluble, then we use a soluble salt solution and a soluble salt solution, and they give us an insoluble salt solution, and we just filter that insoluble salt out, and we can get it separated by the soluble salt. We'll see them one by one. So let's start. Let's start with ionic precipitation. How are insoluble salts made? So barium sulfate is an insoluble salt. We discussed this in the table of solubility. We discussed that most sulfates are soluble, but barium sulfate is an insoluble. Alright, so that is the first thing over here. If we want to prepare barium sulfate, then we need to know its solubility. And now we know that it is an insoluble salt. So how will we prepare that? We have only one method for preparation of insoluble salts, and that is ionic precipitation. So how does ionic precipitation look like? It means that we use ions to get precipitates. Precipitates are solids, they are insoluble solids. So we'll use different solutions. For example, we use a solution of barium chloride, which is soluble, and we use a solution of magnesium sulfate, which is also soluble. So we use two different soluble salts and we mix them. For example, we add magnesium sulfate into this, and we'll see that barium ions and sulfate ions will react each other and they will precipitate out. Barium sulfate will be formed and white solid will start to appear. There are two soluble salts, two clear solutions, but when you'll mix them with one another, they will give you white precipitates. And these white precipitates are of barium sulfate because this is insoluble. Alright? So, and when these white precipitates or once these insoluble salt is formed, you can simply filter it out. Barium sulfate will remain on the filter paper and you'll get a clear solution which is not needed. So this barium sulfate can be easily rinsed with water. You can collect this salt from here. You can wash it. You can wash it with water because it is not soluble in water. Washing with water will have no effect on it. So once it will only just make it more pure. The solutions that are magnesium sulfate or barium chloride solutions, they will have their traces on this barium sulfate salt. So washing it will make it pure from the impurities. So you'll get this salt as a residue on the filter paper and you'll rinse it with distilled water, and you can then oven dry it to evaporate water, and you can so that you can obtain pure barium sulfate. So here are a few steps. I'll just do the same steps again. I'll revise them for you so that it makes more sense. Alright, so let's have one more example, and in this case we are preparing lead chloride, which is also an insoluble salt. So to prepare lead chloride, we need a solution which has lead ions and we need a solution which has chloride ions. Alright, so for lead ions we are using lead nitrate solution, And remember, these solutions, they must they are solutions obviously, so they have to be soluble in water. And for chloride ions, we're using sodium chloride. Both of them are soluble salts, so their solution can be reacted with one another, and it will give us lead ions from here and chloride ions from here. So we'll get lead chloride, which is an insoluble salt. Alright, plus sodium nitrate is again soluble in nature, so we'll have its solution as well. We'll have to separate, or we'll have to filter out lead chloride from a solution of sodium nitrate. So this is how it looks like. You have solution 1, you have a solution 2, you mix these both solutions, and then you start getting precipitates of an insoluble salt. And there is a solution over here as well. So just filter out these precipitates with the help of filter paper, like you can see over here. You can you mix this, you get separate these precipitates or the residue of lead chloride that you need, and you will wash those precipitates with distilled water to remove the traces of impurities, and then you can dry in these precipitates in a filter paper, or you can oven dry them as well, or so that the water is removed and you get an anhydrous salt. All right, so yeah, that is how you get an insoluble salt by ionic precipitation. In the next video, we will see how to make soluble salts, and there are different methods. We have seen 3 methods of obtaining soluble salts. We'll see them one by one.